Hello, today we're going to be discussing surface area of cylinders. First, before we proceed to talking about how to calculate the actual surface area, I want to discuss a few of the key components of a cylinder. First, if we're looking at a cylinder, we have two bases. We have a circle for the base on the top and a circle for the base on the bottom. And remember, we talked about sliding these bases back and forth so that they would meet each other. They are parallel and they are circular. From the center to the edge of the circle, as normal, is called our radius, which we'll just refer to as R. From the top to the bottom of the cylinder, we call H for height. And then this wall covering the outside of the cylinder, we're going to call the lateral surface. Lateral just means the side. So this is the surface on the side of the cylinder. Now the definition of a cylinder is that a cylinder is a solid that has two parallel, identical, circular bases. So these two bases that we looked at are circles, and they are parallel because they are not tilted towards each other in any sort of way. Now, before we talk about drawing the net of a cylinder, I want to recall our animation for drawing nets. So looking at this cylinder here, I have a circular base on the top and a circular base on the bottom. I'm going to move this slider from the left to the right and watch as the cylinder unfolds. When I do so, notice that it unfolds with two circles for the bases going upwards and the other going downwards. Now there's that lateral face also that is unfolding, and as we unfold it, we see that it's a rectangle. So all that happened is we took that rectangle and we simply wrapped it up around the two circles to create the lateral surface. So when we unfold a cylinder, we're going to end up with two circles along with a rectangle for the wall of your cylinder. Now another thing I want you to notice is that the rectangle, if we look at the length of this rectangle, this part of my rectangle is going to wrap perfectly around the outside of my circle. Now let's watch as that happens. That rectangle again wraps perfectly around the outside of the circle. Another thing you might be able to say about this is that that length that I just pointed out, this length of my rectangle, is exactly the same as the distance around the outside of the circle, or what we call the circumference. Now notice again, when I wrap up my rectangle, the height of my cylinder is from top to bottom. Well, when I unfold my rectangle, the width of my rectangle is going to be the same as that height. So this distance from top to bottom of my rectangle is exactly the same as the height of my cylinder. So when we go to draw our net for our cylinders, we're going to unfold our cylinder, and we will have one rectangle for that lateral surface and two circular bases for the top and the bottom. So you can imagine cutting your cylinder right here and unfolding this lateral surface or the wall, and we would obtain this rectangle here in the middle. I then fold this circle up, and this bottom circle we can shade red so that it's a little bit more consistent. This is our second base, and we're going to fold this down. In doing so, we obtain the net here to the right. Now our goal is going to be to find the area of this net. So notice I have two circles. The area of one of these circles is going to be pi times the radius squared. The other is also pi times the radius squared. Since they're the same, really we just have two of those pi r squareds. Now the lateral surface, we did talk about how the length of this rectangle is the same as the circumference of your circle. And the reason that is because this rectangle is going to wrap perfectly around your circle. So this length here in green is the same as the circumference of your circle, which is 2 pi r. So to find the area of this lateral surface, I'm going to find the circumference of the circle, 2 pi r, and multiply it by the height of my cylinder. So altogether, if you'd like to use a formula to find the surface area, our formula would be 2 pi r, this is for our two circles, plus 2 pi r times h, or length times width of your rectangle. We have two circles plus the area of the rectangle. Adding those together will give you the surface area of your cylinder. We're going to find the surface area of this cylinder given. We'll round our answer to the nearest tenth if necessary. First thing we should do is to draw a net. Now I've already done that for you, and it's already labeled as well, so all we're going to do is proceed to find the actual surface area. If you'd like to use a formula, the surface area formula is 2 pi r squared plus 2 pi r h. All that says we're going to do is find the area of each of these red circles plus the area of this rectangle. So the area of one of my circles is pi times the radius squared. Well, I know that pi is 3.14. I know that my radius is 4, and we see that from our picture here on the right. And then I need to square that. Doing my exponents first, I've got 3.14 times 16. And then if you'd like, you may use a calculator to multiply this together. In doing so, I see that 3.14 times 16 is 50.24. So now I have that the area of one of these circles is 50.24 square millimeters. So I have found one of these two circles. However, the one on the bottom is exactly the same, so if I'm trying to find the total area of this net that I've drawn, I need not only this top circle, but I also need this bottom circle. So I'm going to take this 50.24 and multiply it by 2 so that I have 2 circles. And that's where this comes into play. 2 pi r squared, or 2 times one of my circles, which is 50.24. Now if I wanted to add on the rectangle, I first need to find the length of the rectangle and then multiply that by the width. Well, the length of my rectangle here is the same as the circumference of the circle. So if I wanted to look at the circumference of my circle, recall that the circumference is 2 times pi times the radius. So this blue line that I just drew is the same as 2 pi times the radius. Well, I have 2 times 3.14, and then my radius is 4. Multiplying all three of these together on a calculator, we will see that 2 times 3.14 times 4 equals 25.12. So the circumference of this circle is 25.12. So that means the length of this rectangle is 25.12. So if I want the area of this rectangle, I need to multiply length times width. So 25.12 for my length multiplied by 3 for my width is going to give me the area of that rectangle. So multiplying by 3, I find that my area is 75.36. So the area of that rectangle is 75.36. Multiplying the area of my circle by 2, I'll have 100.48. And now using a calculator to add these two, 75.36 plus 100.48, I find that the total area is 175.84. Therefore, the surface area of this cylinder that we're looking at is a total of 175.84 square millimeters. In other words, it will take 175.84 millimeters that are all in the shape of a square in order to cover the surface of this cylinder that we have. For the next one, we're going to go ahead and again find the surface area of the cylinder. So first I'll draw a net. It doesn't have to match exactly, but as long as we get the idea, that'll be sufficient. The rectangle represents the lateral surface, or the wall around the outside of my cylinder, and the two circles are going to represent the bases on the top and the bottom of my cylinder. The radius of the base is 6, so on the top and the bottom I have a radius of 6. And the height of my cylinder is 9, so the height of this rectangle is 9. First thing I'm going to do is find the area of the two circular bases. One circular base has an area of pi r squared, which is 3.14 times 6 squared. Making sure we do exponents first, that's 3.14 times 36. Punching that into a calculator, I see that I've got 3.14 times 36, and that is 113.04. So the area of one of my circles is 113.04 square yards. Now remember, that's only one of my circles. I will have two. So my total area, I'm going to need to take that 113.04 and multiply it by 2. So now I've taken into account both areas of my circles. All that's left now is the area of the rectangle for that lateral surface. The area of the rectangle is length times width. I know the width, but I don't know the length. The length of my rectangle, however, can be found by looking at the outside of this circle. And remember, again, it's because this length wraps perfectly around this rectangle when we fold our cylinder back up. Therefore, this distance is the same as my circumference, which is 2 pi r, which is equal to 2 times 3.14 times 6. And I'm just going to use a calculator to punch that in. 2 times 3.14 times 6. And I find that that length has a distance of 37.68. So the length of this rectangle is 37.68 yards. So the area will be that length multiplied by the width, and that will allow me to figure out the entire area inside this rectangle. So I'm going to add that onto my circles. Length 37.68 multiplied by the width, which is 9. And from here we just do the calculations. 2 times 113.04 will be my first calculation. And I find that that is 226.08. My second calculation will be the 37.68 times 9. So 37.68 times 9. And I see that that's 339.12. And now my last step is just to add these two together to find the total area of the net that I've drawn. So I'm going to add on 226.08 for a total of 565.2. So what I have found is that this cylinder has a surface area of 565.2. My units are yards, and since we're talking area, we want square yards. Or another way to say this is that it will take 565.2 yards that are all in the shape of a square to cover the outside of this cylinder. We'll go ahead and stop here for today. Thanks so much for watching.